All right, good morning. Happy Thursday. I don't know about you, but I'm ready for a week off. So I'm happy for all of us that we get to take a little bit of a break. So I decided not to give an exam on Friday morning. And what I want to do today is I want to try to do a real structured review on some things that I taught in 1.7. So what we're going to be doing is do something on the board. You're going to go to the teams. You're going to come back. I'm going to do something on the board, teams, back and forth. So, I need you to fully today. Get a little upset about period one because they just seem like they're completely out of it, and it makes me not want to stand up here and teach. They did better at the end. I'm pretty upset. But anyhow, I need you to be engaged, be here with your mind, and be us that we're doing to review 1.7. Now, when we come back break, I'm not going to give it away, but and I'm also not going to probably give a test on 1617. It's probably going to be 4. So you have a grip because when we come back, I'm going to teach a new lesson. So you can't come for everything. What I want to look, keep your books open to page 258. I'm going to look at problem number 32. And I'm going to have you do 31. And if you've already done it, you're going to do it again. If you've already done it in your assignment. So F is linear and G is linear. And they want you to, first of all, add them. So simple, add them. So the F function is 3x minus 4, and the G function is 2, and you just combine like terms. So 3 plus 1 is 4x, negative 2 plus 2 is negative 2, and then they want you to state the domain. Now, the domain is where the graph exists forever, left and right. So I need you at this point to recognize this is a line. And if this is a line, that means it goes forever, left and right. Then I want you to subtract. To subtract, you're going to take 3x minus 4 minus, and make sure you put this quantity in parentheses so that you don't fail to distribute. So this would be 3x minus 4 minus x minus 2. So your result would be 3 minus 1 is 2x, and a negative is a negative, and you add. Do not divide by 2. This is an expression. So in this case, this is a line, so it exists forever, left and right. In C, they want you to multiply. So you take F in parentheses, and you take G in parentheses, because you want to see that you got to know you're going to FOIL, right? So when you FOIL, first, outer, inner, last, you get 3x squared. Outer would be 6x, inner would be negative 4x, and last would be negative 8. So your final answer in standard form, 6 minus 4 is 2x, is a quadratic. Well, what is the domain of a quadratic? Forever, left and right. And then finally, you're doing division. So you're taking 3x minus 4 divided by x plus 2, and that is the final answer, because it cannot be factored or anything else. You can't cancel parts of a sum or a difference. You're done. Now, what you want to notice about this for the domain is this is a rational function because there's a variable in the denominator. So you have to throw out excluded values. So what can X not be?
-2.
Right. And you're only worried about the bottom. Don't look at the top. So you're done then. So the domain is negative infinity up to -2 or -2 to infinity. So in other words, it's everything except -2. Okay, so anybody have any questions about this? All right. You guys are going to do, what problem did I just do? Did I do 32 or 31?
You did 32.
Okay. You guys are going to do 31. I don't care if you've done it or not, do it again. F is a line, 2x plus 3. And G is also a line, x minus 1. What you're going to do in your team, add, multiply, and divide. And I'm going to give you time to do it. Now listen, I'm going to hold period 1. When you guys have your video off, you are making it more hard than the way the situation's already hard. When you have your video turned off, you are making it even harder. Because if you had your video on, you could hold up your paper if somebody didn't understand what you were saying. In my Algebra 2 class, one of the teams, they always have their video on, and one of the students has a whiteboard in her room and works the problems as the team is telling her what to. She works the problem. It's highly effective. So let me encourage you to think about in the future, turning on your video. You guys are making it more difficult than what more difficult than what it is. It's already difficult. But if you had your video on, you could hold up your paper. Yeah, and work. So anyhow, some school districts are forcing students to turn on their video. I was in that district because I think we should force students to turn on their video because otherwise it just makes it more hard than what it is. Anyhow, it's 11 o'clock. I'm going to give you 10 minutes to do this. All right. So your teams, in order to do it in 10, and they have to work together. So make sure that you say the steps so that everybody has it. And I'll see you back here at 11:10. All right. I'll see you back here at 11. All right, so one thing, if your team finishes, do another problem. So I just want to, when we do things like this, I just want to practice. I don't want to do like 2 problems in 45 minutes and we're just sitting around doing nothing. So work another problem together. And please, 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 I know these are new groups, so I'm just going to take the benefit of the doubt saying that you're just shy with your new group, but please do what I'm asking. I'm the teacher. Let me be the leader. Please follow. Okay? So I don't want you to work the problem and then see if you all have the wrong answer. I want it done right the first time. And the goal of this team stuff is for everyone to be able to do the problem correctly. So if you could just please state the steps. Somebody take the initiative and state the steps. And you can trade off. One person shouldn't have to do it. And please just follow my leadership. All right. So the first thing you're going to do is add. So this would just be 2x plus 3 plus x minus 1. So you get 2 plus 1 is 3x plus 2. Okay, that is a line. So what is the domain? All real numbers. Okay, then you're taking f minus g. So that means what? 2x plus 3 minus the quantity. Because if you write this, it's already wrong. It isn't even right. So it's minus the quantity. So this would be 2x plus 3 minus x plus 1, because you have to distribute. And now you get 2 minus 1 is 1x plus 4. So that is a line. So what's the domain? All real numbers. So in C, you have f times g. Well, what does that mean? It means that quantity times that quantity. So it has to, they both have to be in parentheses. If you don't put them both in parentheses, it's wrong. So now you FOIL. So first would be 2x squared, outer would be minus 2x, inner would be 3x, and last would be negative 3, and you combine like terms. 3 minus 2 is 1x, and what is that? That's a quadratic. So what's the domain? All real numbers. So then finally, you have f divided by g, which would be 2x plus 3 divided by x minus 1, and there is nothing left to do. That is the answer, because you can't factor to simplify, you can't cancel parts of a sum, you're done. So what can you not have in this problem? This is a rational function. What can you not have in the denominator?
Positive 1.
Right. So the domain then is all real numbers except 1. Okay, now that was just a warm-up. So what I want to make you focus on is these compositions. And I'm talking about problems 51 on. Okay, does anybody want to ask me about this before I erase it? All right, I'm going to do problem number, I'm going to do 55. And you're going to do an easier one. So 55 says that the function is, for f is 4x minus 3, which is linear. And the g function is a quadratic 5x squared minus 2. So in A, remember we talked about the composition the other day. And I explained that the definition is f of g of x. So write it down. So you work from the inside out. So you bring the f down and you put the g function in. So now what you have is f of x, but you have a new x. You have this thing, it's an x. So this thing represents x. So what you're going to do is you're going to look at the f function and go, okay, I'm going to take that old x out and I'm put the new x in, which is 5x squared minus 2, and you're going to multiply this out. So this would be 20x squared minus 8 minus 3 is 20x squared minus 11. And they do not ask for the domain. Good, let's not do it. Okay, in B, they want you to do this. And what that means is g of f of x. So now we drop the g down and go on the inside, f. What is f? Over here, 4x minus 3. So now that's g of x. Well, this is g of x over here, right? And g of x is 5 times x squared minus 2. So we're going to take that x out, the new x in, which is 4x minus 3. So this is a lot of work because this is 5 times 4x minus 3 times 4x minus 3 minus 2. So you're going to have to FOIL first. So this FOIL would be 16x squared. The outer would be negative 12x. The inner is negative 12x for a negative 24x. And a negative times a negative is a positive 9. And you distribute the 5. So that's 80x squared minus 24 times 5 is what? 120x plus 45 minus 2. So this would be 80x squared minus 120x plus 43. And that is the answer. That's my book. This is problem number 55. That's correct. And now they want the domain. Well, this is a quadratic, so it's just all real numbers. Okay, now I'm going to do the next one problem. So there's a C and D. Okay, here's C. C is f of g of 2. So they're going to want you to evaluate this one. So this is f of g of 2, and we're going to work from inside out. We're going to put 2 into the g function. So in other words, we're evaluating g of 2. So inside here, 5 times 2 quantity squared minus 2. So what is that? That's 5 times 4 minus 2, which is 20 minus 2 is 18. So now that becomes the x of the f function, which is 4 times something minus, and now the something is 18. So 4 times 18 is, I think, 72 minus 3 is, what is that, 69? If I look, 55C is 69. Now, see how important it is going to be for you guys to talk through your stuff? Because now you don't have a two-step problem. And it's going to take you 5 minutes to do this. And if you mess it up, you have to go back and do it again and do it again. And it's just a big waste of time. That's why I've been trying to get you to talk through your steps, because I've been trying to train you to do that so you could do this problem correctly the first time. So this is g of f of 2. So this means g of f of 2. So you're going to evaluate f of 2, so put a 2 in. So it'd be 4 times 2 minus 3, which is 8 minus 3, or 5. And now we're evaluating the g function. So that would be 5 times 5 quantity squared minus 2, which is 5 times 25 following the order of operations. So 5 times 25 is, I think, 125 minus 2. So the answer is 123. Did they have you do that? 55? Yeah, they didn't put the D's in my book. That's weird. I never noticed that before. So then they didn't put the answer for D in my book. But this is the answer, 123. So it's going to be critical that you don't skip a lot of steps on this, because if you do, you're not going to get the right answer. Now, the problem I just did was a little bit harder than the one I'm going to give you, but basically that's what you're doing. I want you to do number 51. And 51 is a linear function, 2x. Darn it, my board's wet. And g of x is x plus 7. So they're both linear. And you're required to do 4 compositions. It's 11:24, and I'm going to give you 15 minutes. So 11:40. If you do not work together, you will not finish by 11:40. So I'm hoping that you'll just work together and state the steps as you go along. G of f of 2, g of 4 times 2 minus 3, g of 5. And someone just take the initiative and steps as you go through this. All right, I'll see you back at 11:40. Okay, you guys, I had the right problem at 51.
Yeah.
Okay. So most of you could do this, but what's scary is I can't see your notation to know if I gave you a much more difficult problem, if you could do it. So just when I go over this right now, just pay attention to your notation and make sure your notation looks like mine. So in B, you should have g of f of x. And the f function you're going to put in is 2x. That becomes the x of the g function. So the g function is something plus 7, and the something is 2x. Is that what you got?
Yes.
Okay. And then they wanted you to evaluate the composition of f of g of 2, right? So this means f of g of 2. So working from the inside out, you're putting 2 into the g function, which would be 2 plus 7, which would be f of 9. So now you put 9 into the f function, which would be times 9 or 18. And I think that's what most of you got. And then in D, let's see if I can just work it over here. You got g of f of 2, which is g of f of 2 by definition, which is g of, you put a 2 into the f function, which would be 2 times 2, which is g of 4. So now you go back to the g function and put a 4 in, and I think most of you got 11. So just make sure that your notation is really similar to this. Okay, so let's move on to something else now. Let's move on to a more difficult composition on number 67, those problems. Okay, I'm not going to do 67. I'll leave that for you. I'll do 69. So in 69, you have a rational function. And the rational function is x over x plus 1. And what makes it rational is the variable in the denominator. And then your g of x is 4 over x, which is also rational. So they want us to do the composition first of f of g of x. This means f of g of x you guys see that? So we're going to do what we did before. We're going to put g in. That becomes the x of the f function. So wherever you see an x, you have to put 4 over x. So you take that x out and put in a 4 over x. And then you take that x out and put in a 4 over x plus 1. Now, this is a complex fraction. And so you cannot leave the answer like that. So what we have to do is, this one on the top is simplified, but on the bottom, we're going to have to get a common denominator. So this is going to be 4 over x divided by 4 plus x over x, right? 4 plus x over x, a common denominator. And now that it's simplified, can't cancel those x's, you lay the stack out flat. So now you have 4 over x divided by, I'm just going to write that as x plus 4 divided by x. And remember what you do? You change it to multiply and take the reciprocal. So because this is multiplying, you can't cancel those x's. So you end up with 4 over x plus 4. And that is the composition. And now they want us to find the domain. All right, so if you look throughout this entire problem, you do not see x over x plus 1. So if you were thinking, oh, we have to throw out a -1, there is no x over x plus 1 in this entire problem. So -1 is a good answer. But when you look through the rest of the problem, you see this right here? Can't have a 0. Down here, can't have zeros. Over here, that's kind of confusing to look at, but if we look at this, can't have a 0. And what else can you not have right there?
-4.
Right. So that's your domain then. Your domain would be everything except -4 and 0. So you would write negative infinity up to -4, or -4 up to 0. I'm just putting it in order. Or 0 to infinity. So with this set of problems, it's like a step above because they're wanting you to work with these rational functions, and then you have to find the excluded values to state the domain. All right, does anybody want to ask me about any of these steps? All right, let's try it then. You guys are going to try to do number 67. Okay, so 67 is f of x equals 2 over x plus 3. That's rational. And the g function is also rational. It's 1 over x. What you're going to do is two things. You're going to find the composition of x, and then you're going to find the domain of the composition. All right, so let's see how that goes. So I'm going to give you 10 minutes. So I'll see you back here at 12. All right, I'll see you back here at 12 o'clock. Call me over if you need help. All right, so for 67, you have two rational functions, and they want you to do the composition, f of g of x. So we do what we did before. You bring down the f and put the g function in, 1 over x. And that thing becomes the x of the f function. So that means in the f function, you take out the x and put in 1 over x. So when you do that, you're going to have to get a common denominator and simplify the fraction. We did this in the prerequisite section. So you get 2 divided by 1 plus 3x over x. You're adding fractions, right? Right? 1 plus 3x over x. So now you take the stack and lay it out flat, which would be 2 divided by, I'm just going to write 3x plus 1 over x. Change it to multiply and take the reciprocal. So your composition is 2x over 3x plus 1. when you go to find the domain, you first think, oh, x cannot be -3, but 2 over x plus 3 appears nowhere in this problem. So therefore, -3 is not a problem. But what is a problem is you cannot have a 0 there. You cannot have a 0 over here. And what else can you not have? You can't have what makes that 0, right? So if you can't tell what it is, you take 3x plus 1 and set it equal to 0 to find the excluded value, which would be -1/3. So x cannot be -1/3. So the domain is everything except those guys. So this would be 0 up to -1/3 open, or open on -1/3 up to 0, or 0 to infinity. Questions? So the first part of 1.7 is finding the domain. On number 31, you're adding, subtracting, multiplying, and dividing. On number 51, you're finding these different compositions. And then 67 is a little bit more complicated because they want you to find the composition and then the domain of the composition. And then you see problems 75 through 82. Those are the easiest problems. What they're doing on this is they're giving you the composition and they want you to write the two functions. So they want you to go backwards, which is actually easier. Would any of you like me to do anything 75 through 82?
Number 73.
You mean not 73, you're talking about 70. The next section is 75 through 82. Do you want me to work any of those, 75 through 82?
Oh yeah, sorry. 77.
So they're giving you a composition. H of x equals the cube root of x squared minus 9. And they want you to find the two functions that when you take the composition, you get. So this is really simple. Rather than working from the inside out, you're going to work from the outside in. And you ask yourself, who's the parent? And the parent is the cube root of x. It's what's outside. And now you just put what's inside, and believe it or not, the answer, I'm going to prove it to you. I'm going to show you the composition, and we're going to get h. So you put the g function in. That becomes the x of the f function, which is the cube root of x. So it worked. Now, somebody asked me last period, do you have to do this proof all the time? And the answer is no. I'm just showing you, it's real quick to check if you got it right. You should come up with h. Maybe you want me to do another one? Want me to do 80?
Yeah, please.
Okay, so in 80, h of x is the absolute value of 3x minus 4. So all you have to come up with is f and g. Well, instead of going from the inside out, we're going from the outside in. So who's the parent on the outside?
Absolute value of x.
Yeah. And what's inside is 3x minus 4. And that is what makes the composition. I'm just going to show you f of g of x. So x is 3x minus 4. And when you put that into the f function, it's the absolute value, which is h of x. All right, so anyhow, I hope you guys have a great week next week. I just want to thank all of you who come to class every day. I want to thank all of you who are legitimately doing work and legitimately trying. I am thankful for you, and it does make it worth it for me to teach because this is a frustrating time. I am a little upset today with the people that are acting like they come to the meetings, but they're not really here. People who are coming in late, people who are leaving early and not doing what you would normally do at school. I feel like it is disrespectful for me that I'm pouring out my heart and soul for you, and you're not giving the same back in return when this is for your own benefit. So anyhow, I hope you guys have a nice Thanksgiving. I am thankful for you, and thank you for all your hard work. I hope you guys have a great week off. Okay? All right. Have a good week.